My name is Brent Sturlogson. I'm a licensed architect and assistant professor in the School of Architecture and Planning at Morgan State University, where I teach graduate design studios and serve as the faculty director of the Built Environment Applied Research Lab. Today, I'm going to talk about an ongoing research and design project we're calling Mass Retrofit, which at its core examines the intersection of vacancy, housing affordability, and climate change in Baltimore. As an architect, I'm drawn to projects that really stretch the disciplinary boundaries of conventional practice. And as a faculty member at Morgan State, my work contributes to its designation as the preeminent public urban research university, which we take very seriously, to address challenges that confront Baltimore communities specifically. So the project I'll talk about is interdisciplinary by nature and involves faculty, students, and design and construction professionals. And as one part of this team, I'll discuss some of the research and design work that we've undertaken, starting with a little bit of project context, followed by a summary of our research questions and design methods, and then close up with some preliminary findings and some next steps. So by way of background, one of the enduring challenges that many communities face in Baltimore is the persistent presence of vacant buildings and the adverse impacts that accompany vacancy. Depending on whose data we're using, the number of vacant properties in Baltimore hovers around 15,000 at some of the lower estimates, to as high as 30 or 40,000 by other measures, again, depending on whose categorization you use. At the same time, housing affordability in Baltimore has reached a similar level of crisis as many American cities have seen. Like vacancy, housing affordability, of course, can be defined in a variety of ways. But according to just one of these measures in 2023, the Housing Authority of Baltimore City received a record number of requests for housing support, seeing nearly 30,000 applicants for a supply that only serves about 5,000 residents. Meanwhile, of course, the effects of climate change grow increasingly severe. And these days, we know the enormous impact of manufacturing new building products from scratch. And yet the prevailing strategy for managing vacant buildings is centered on widespread demolition. One example we're seeing here underway. And while there are many admirable renovation and retrofit projects ongoing and have been for decades, much of the local, state, and federal funding that targets vacancy in Baltimore is dedicated to demolition as the kind of prevailing method of management. So for this project, we're asking a series of research questions. Number one, how can building designers adapt the urban environment to improve access to affordable housing? Number two, what opportunities exist for the integration of digital technologies throughout the design and construction process? Number three, how can these adaptations be applied in historic urban centers to reduce material consumption and preserve existing morphology? And fourth, most importantly, who benefits from these processes and how? The project, as I mentioned, leverages a suite of digital technologies in the analysis, design, and construction of prefabricated housing components at scale. This is our important, I think, emphasis here that addresses the scalar question. Using handheld, aerial, and ground-based scanning technologies, we're creating high-resolution digital models that establish the precision and detail that will be needed for offsite construction. Here's a kind of point cloud scan of one kind of case study block. Secondly, we're also using geospatial tools to establish some broad characteristics of vacant properties across Baltimore, which will help prioritize retrofit efforts. So here we're demonstrating a geospatial algorithm in a case study neighborhood, starting with sort of general occupancy analysis, looking at lots that are both occupied by buildings, vacant and occupied, but then also a kind of parcel analysis showing what's been demolished already. One kind of unique characteristic of the data set of building data in Baltimore is that we don't have a comprehensive data set for building height or building volume. So while we know how many vacant properties are in the database that the city maintains, we don't know the characteristics of those buildings. So here what we're doing is, again, using a different set of geospatial data to begin to approximate this in terms of a kind of volumetric analysis, starting with an aerial image, digital elevation model, and a LiDAR scan that then, performing what's called a little bit of map algebra, we establish a volumetric gradient that can give us a good approximation of a 2-story, a 3-story, a 4-story unit that then we can use in some of our prioritization of retrofit design components. So here we're looking at that same analysis at a zoomed in scale. We can see, again, for purposes of prioritization, properties that the city already owns, the results from that volumetric analysis about how many 1, 2, and 3-story buildings we have in the case study area. And then we can sort of isolate this generated data set to designate vacant properties. On the right, we can see, in this case study neighborhood, clusters of vacant 2-story building volumes, clusters of 3-story units, and then again, for purposes of prioritization down the road, indication in black outline of city-owned properties. And then we can further isolate this data into standard units, right? A lot of these buildings have a lot of non-standard dimensions. So part of what our scanning is helping to generate is some amount of standardization or kind of regularized components that might satisfy some of the retrofit agenda. But here we can see the 12-foot wide units being isolated, clusters of them in the southwest area of this case study neighborhood, 13-foot wide units more scattered around the neighborhood. Again, we can establish some priorities that what the city already has control of, highlighted in the black outline. In this particular area, the 14-foot wide unit is the kind of dominant unit type, most, if not all but 4 or 5 of them in the 2-story, in this 2-story volume. So we can get a pretty clear picture of, in this case, 146 units in this neighborhood of vacant 2-story buildings that can start to establish a pretty strong case for mass retrofit, right? Not treating them as one-off solutions for renovation, but standardizing some of the processes we can achieve and efficiencies we can achieve with offsite construction. Another list of, in this case, 87 15-foot wide units, some of them clustered in 3-story units along a main street on the perimeter, and fewer 16 and 18-foot wide units. So again, using publicly available data from LiDAR scans, digital elevation models, we're able to give stronger characteristics to the landscape of vacant buildings across Baltimore, here demonstrated in one case study neighborhood. So from this list that we're generating of units that could be candidates for offsite pre-construction of housing retrofit components. We can then get into some of the more detailed scans to then confirm some of the design solutions we're proposing. So in this case, we're simulating in the digital space a sort of process of how the retrofit might work. So again, in an offsite capacity where we know there are lots of gains in efficiency relative to insulation, to coordination of trades, to material consumption, these, say, floor panels, the utility cores, the stair, things that would typically be built on site in a custom fashion can be produced offsite and shipped to the location, in this case, starting from the ground up after kind of remediation and removal of previous material has been done, followed by a ground floor. Again, the kind of prefabricated nature of floor panels and wall assemblies as panel-based units, and then these volumetric cores, such as the kitchen core, bathroom cores, where again, plumbing and electric can be efficiently integrated offsite, such that on-site work can be much more efficient, and then expanded capacity can result from that. Upper floors, again, in a similar fashion, the utility-heavy cores could be fabricated as volumetric components, and the panel-based elements, walls and floors, and roof can be lifted in turn. Again, sort of demonstrating the kind of digital proof of concept in this case. The process has been demonstrated by others in Baltimore at a kind of one-off scale. Again, what we're looking for is how to scale up the process to achieve efficiencies and affordability across the city. So here, the process would typically begin with a hazardous material assessment and abatement process where teams go in and sort of understand what contamination exists and the removal and disposal of that before deconstruction can begin. Certain elements can be recycled, others can be reused. So there's the deconstruction phase. Following this, we would take detailed readings from, again, ground-based, handheld, or aerial-based scanning to produce that high-resolution digital twin that can be used then to kind of customize some of the offsite prefabricated components. And then after construction, those would be sort of assembled in place, and the finishing work would be done much like it is in conventional renovation practice. Windows, doors, envelope would be sealed on site. The result of this work, again, on an individual basis is helpful, but our proposition here, our value proposition is, again, the scaling up of what we know to be an efficient use of material, an efficient use of labor, and in the production of a vastly increased housing supply, which on its own would improve affordability. And again, through the kind of scaling up of these processes, could effectively get us closer to reaching housing affordability and combating some of the material waste that contributes to landfill overflow and adverse climate impacts. So here we're looking at some of the energy efficiency criteria that we're looking at in the design of these components, which would include robust insulation, high performance glazing, efficient heating and cooling systems. Again, all as prepackaged units that we've known to be effective in the manufacturing housing manufactured housing sector, but now treated in a specific case that would address the vacancy issues that we see in many Baltimore neighborhoods. Thank you.
Brent, that was great. Great, great. Thank you so much. I got a few questions for you. Do you have a few minutes?
Yes, of course.
Okay, great. I love this concept. I think it's very innovative and exactly what we were looking for. I'm a huge proponent of offsite construction for a myriad of reasons, but I think that's definitely the way of the future, building offsite to, overcome, the labor challenges and some material and challenges in that regard. So the case study neighborhood, are you able to explain where it is and what criteria was used in its selection?
Yeah, the criteria we used was based on density of existing vacancies that the city maintains in their database. It's in West Baltimore, and the selection criteria was again based on density, so we could test some of um, the geospatial techniques to see if it would result in usable data. So again, we could have sampled from any number of neighborhoods. The idea being we could take this as on a kind of neighborhood basis to generate a list of prioritized properties that using the algorithm in a repeated way could effectively cover the city, right? Down to each district that sees a high rate of vacancy.
Understood, understood. And it looks like the choice was strategic, I guess, to go the retrofit route versus the new construction kind of vacant, because there's a lot of vacant lots. The number of I've always heard is around 21,000 vacant lots. Do you see this solution transitioning into new construction on some of the vacant lots, or is it pretty much a retrofit solution?
It's a great point, and I'm glad you brought it up. I think the opportunity for offsite for applying offsite construction techniques on these empty lots is it's prime, right? It's the opportunities are there. I think we started with retrofit because I guess we've noticed this impulse to demolish being so strong that again to kind of preserve some existing morphology where possible. The retrofit was our top priority. It is our top priority, but absolutely for some of these areas that have seen a lot of kind of demolition on a block-wide scale or in the kind of piecemeal approach, could certainly be strong candidates for, again, infill using offsite methods.
Yeah, I've like I said, I've been geeking out on the urban infill kind of offsite volumetric versus panelized um opportunity, and have made a couple of trips to Pennsylvania, to Pittsburgh to visit some factories, visit some models and out to Delaware as well. And the price points for these types of projects can range from, $80 a square foot to $400 a square foot. Are you guys kind of getting into the weeds in regards to what it's looking like, on a budgetary level of what the price is to square foot to do a retrofit?
It's within our scope. Yes,
Okay.
I have a project partner who specializes in cost estimating, so it's within the scope, and to be to be undertaken in turn. But yeah, it's certainly something we're tracking. Because again, it's important in our series of research questions to ask who benefits, right?
Right.
Who gains from a process that's leveraging digital technology, construction, assembly processes. Um, so yeah, cost is a huge consideration of ours that will be, yeah, an important bridge to cross once we sort of sort out some of the workflow on the digital front and the design front. So yeah, incredibly important.
Yeah, for sure, especially when you're talking about, appraisal gaps and, city subsidies, state subsidies. I guess the federal subsidies are not happening so much nowadays, but okay, so talking about maybe third-party environmental certifications, are you going after any, zero energy ready? Have you're looking at solar, you're looking at charging stations, indoor air plus, Energy Star. Would these properties have a third-party environmental certification that goes along with them?
Yeah, I think it's a great target. I'm not an expert in the certification space. I'd love for some more advice on that or more guidance. But I think in any case, the goals for us are, first affordability, right? But we can achieve affordability through efficient use of material, through energy efficiency, right? We know that a big contributor to housing unaffordability is monthly utility bills. So if we can do what we can as designers and builders to minimize that, I think we're also achieving a goal of affordability. So any certifications and support that we can get through the design specs would be certainly another priority of ours.
Absolutely. I think not to overburden you with with things
Please.
to add to your plate, but the one thing that I didn't hear nor see was addressing kind of the number one determinant of health, which is the home and the health and wellness of the occupant. Kind of leading with indoor air quality, which is something that I'm extremely passionate about because Baltimore has the eighth highest rate of asthma emergency visits in the nation and the second highest rate of asthma related fatalities in the nation. And, the neighborhoods that you're talking about in West Baltimore lead those stats.
Mm,
So I guess that's what I'm asking about, indoor air quality and maybe some certifications or because an emergency visit on average costs about, the taxpayers about $900 per visit, but an overnight stay for an emergency related to asthma costs about $10,000. And so the state of Maryland spends about 68 million for Medicare for these types of emergencies, and I'm thinking that healthy homes is definitely a way to cut that back. And those savings, I think, are a lot more than energy savings when you can increase the
yeah.
health and performance and productivity of the occupant, especially when a lot of people are working from home.
Yeah.
So
No, another I think really great point and something certainly to kind of factor into some of the cost analysis that we'll be doing is those maybe spillover effects of the unhealthy indoor air quality. And I think another feature that kind of struck us early on um, is the contribution to air quality issues that the demolition brings to these neighborhoods, right?
that's right.
There
That's
certainly
right.
is this kind of protocol for spraying and mitigating what you can. Having seen these projects being demolished, no matter what you do, right? We're letting out quite a lot of toxic material into these neighborhoods with very few precautions, sadly. So, yeah, there's the contribution from demolition to the toxic airborne particulates, but then absolutely how can the home itself be a robust filter for sort of yeah, promoting health.
Yeah, yeah, definitely. The home can either keep us well or make us sick.
Sure. Yeah.
And
Yeah.
because we spend 90% of our lifetimes indoors and 70% of that is spent in our homes,
Mhm.
about 14 to 16 hours at home, and the majority of that time is spent in the bedroom, that if we're going to breathe toxic air, 70% of that time we're breathing toxic air, we're breathing it inside of our home. So,
Yeah.
so it really can be that beacon of health for sure.
Yeah.
Okay, just a few other questions. This is great. So it looks like you've chosen a panelized and kind of volumetric hybrid. I've often seen builders, developers kind of go either well, definitely for new construction, the volumetric approach. But on the retrofit, I haven't seen much panelized, but it looks like you're am I wrong in assuming that you're looking at more of a hybrid?
You're right. Yeah, that's exactly right. And you know, there there there's competing theories for efficiency, and when we talk about, retrofit of a built environment that's kind of as bespoke as we see in Baltimore, um, it's an open question. I think where we settled on the kind of hybrid nature is just in the again cost and efficiency of panel-based systems, and where needed, the volumetric um, components could have kind of more integration of the wiring, the plumbing, the features that I think require a little bit more control. But as far as floors and walls, I think, again, understanding that the character of these, vacant units in Baltimore, we can't always assume walls are vertical. We can't assume corners are square, right?
Right,
So
right.
how can we build in, and that's some of the work we're doing now, is how can we accommodate for that tolerance that is often quite wide, right? When we compare it to, let's say, a greenfield prefabricated project where you can control tolerances pretty tightly. But when we deal with an existing built environment, those challenges are a little bit different. So yeah, the hybrid system is our working theory. Um, and yeah, I think the when we can start to kind of scale up and test certain outcomes, we'll have a clearer answer of where we might see the most efficiency.
Yeah, yeah, for sure. So then, yeah, I mean, because you're talking, 120, 150-year-old homes,
Yeah.
that have that are not plumb, for sure. So how close are you to actually creating that first case study is my first question. And the second part of that is, I've heard that there, and I don't know if you've gone down the rabbit hole with city permitting and zoning and stuff like that, but I've heard that cranes carrying either panels or um, modules over existing homes is not allowed in Baltimore City. I don't know if you've run into that quite yet, or what your opinion is on that.
Yeah, so the first part of the question is kind of how close we are to, we'll say, a pilot project. We're focusing our energy right now on designing the systems. So for example, we don't have site control of a vacant unit at the moment. Um, I have some project partners that are sort of more based in the professional culture of design and construction, who are working that front more concertedly, I guess. At Morgan, we are studying the sort of integration of technology and efficiency at scale. As far as the rabbit hole of permitting and stipulations on forms of installation, um, we know the system can work, right, and that we can get through the any kind of regulatory not loopholes, but hurdles that we need to overcome. The kind of proof of concept that we're teasing out here at a massive scale has been achieved. We've seen it done on the single house scale, right? Craning components in from either the alley or the street. So we know it's possible, and we've yet to fully comprehend all of the restrictions around the process. We do have construction management specialists on the team, which would, I think, be prepared to sort of address those.
So what would you say is your biggest barrier to adoption, and then your number one need? Like, what are you looking for, either from the community that's watching this or from Morgan State or the city or the state? Like, what are the barriers to adoption, and what's your number one need to move this amazing innovation forward?
Yeah, I think what we're seeking now on the research and design front is external funding to support some of the I'd call it programming of some of the design work. So we've established a digital workflow from the geospatial citywide scale down to the individual unit scale. But right now, each of those processes is quite manual, right? We're out there scanning, we're in the data, kind of putting things together. What we're hoping to do with external funding is find a way to make that more user friendly. So it's not in the hands of, researchers with, the time and resources to kind of create that connection. And the other one, again, that my project partners in industry are more focused on is application and assembly, right? We're really interested in developing a system for offsite construction in Baltimore, right? It's not something that we're
Mhm.
looking for project partners to fabricate elsewhere.
Mhm.
It's really there's a desire for part of the process to be a kind of economic engine as well. And that, of course, requires incredible capital, and appropriate site. And yeah, again, some project partners of mine are more focused on that. One interesting and kind of exciting spin-off from this project is happening right now. I'm working with some graduate students at Morgan to create a speculative design for this design and research and manufacturing facility. So we've got, yeah, 8 really talented architecture students looking at this. And part of that project is in collaboration with a planning course at MIT, who's also looking at some more kind of property and probate issues with obtaining site control for some of the vacant units. So
Mhm.
there's some exciting work happening, which is yeah, to be seen as a kind of motivation for the project from here.
And what's the best way for people to follow your work? Is there a website? Is it email? Is it where how can people kind of follow its progression?
Yeah, we churn out academic conference presentations and papers at the moment. You can reach me by email in the bottom corner. Would love to interact and hear questions or thoughts. And as of now, we don't have an active kind of social media feed with project updates, but we'll we'll work on that, right? But for now, we can be found on the Morgan State SAP planning website, and by email.
Awesome. Hey, Brent, this was, like I said, exactly what we were looking for. I love what you guys are doing, especially, with the digital twin, the 3D kind of volumetric space, the deep spatial data space, the offsite construction. These are all things that are very exciting, and the whole energy efficiency space and the affordability as well. So I definitely want to thank you for your thought leadership and your subject matter expertise, and taking time out of your busy schedule to update us on what's happening with mass retrofit here in Baltimore.
Great. Thanks, Aaron. So great to talk with you.
Thank you so much. Have a great day.